Hello students, I Mrs. Madhavi Mhatre welcome you all in the next lecture of Mathematics 1. We are studying chapter number 5 probability. And in this chapter we have completed discussion of all the topics and we have completed all the practice sets. And finally in the previous lecture we have started with problem set 5. In that we have discussed MCQs and then we have discussed question number 2 and 3. Now let's go ahead towards next question. Okay, so let's start with fourth question in problem set 5. Joseph kept 26 cards in a cap bearing one English alphabet on each card. One card is drawn at random. What is the probability that the card drawn is a vowel card? Okay. So now let's first of all write down the number of sample points here. Here 26 cards are there and we know that there are 26 English alphabets. So there is no need to write down the sample space. Simply you can write down the number of sample points. Okay. So here you can write down the event. Writing event from the question is very much important, or the experiment which is done here, that you need to write down here, that Joseph has 26 cards in his cap. That is the experiment. Now since he is having 26 cards, we know that n of s is 26. And then we are writing here that each card bears an English alphabet. So it gives it the idea that every card is having the English alphabet from A to Z. One alphabet on one card. Okay. Now let's see the event. What is the probability that the card drawn is a vowel card? So this is an event. So write down that as event A. That let A be the event that the card drawn is a vowel card. Now you know that we have 5 vowels in English: A, E, I, O, U. Okay, so we can write down here that there are 5 vowels in English alphabet and therefore n of A is 5. And then we have to find the probability. So write down the formula for probability. P of A is equal to n of A upon n of S, that is 5 upon 26. Okay, so it's very easy question. Such questions will come for 2 marks. Okay, but writing all these things are very much important. Write down the experiment, then write down the number of sample points, then describe the given event. Take in any one English alphabet for that particular event, and then you can write down the number of sample points in that particular event. And then writing the formula is very much important, that P of A is equal to n of A upon n of S, and then simply put the values 5 upon 26. If possible, reduce it to lowest form. Now here it is not possible, so that is our final answer. Okay. Now let's go ahead towards the next question. Question number 5. A balloon vendor has 2 red, 3 blue and 4 green balloons. He wants to choose one of them at random to give it to Pranali. What is the probability of the event that Pranali gets first one a red balloon, second a blue balloon, and third a green balloon? Okay. So first of all, write down the experiment. What the experiment here is, that the balloon vendor is having 2 red, 3 blue and 4 green balloons. Write it as it is. Okay. So you can write down the total number of balloons here as 2 plus 3 plus 4, that is 9, and therefore number of sample points here n of s is 9. Okay. Now here there is no need to write sample space in the form of set. When you write RR for 2 red, blue, blue, blue for 3 blue, then you know that repetition of elements is not allowed in the set, and then you are writing wrong set. Instead, don't write that sample space as a set. Simply you write down the total number of balloons, and from that you can write down total number of sample points as 9. Now here one balloon is selected at random so that the vendor can give it to Pranali. So now the first event here, that the pranali gets red balloon. So write down as event A, that let A be the event that pranali gets a red balloon. Now how many red balloons are there here? Two red balloons are there. So write down that total number of red balloons is equal to 2, and therefore n of A, number of elements in this particular event, are 2. Now immediately we can write down the probability that P of A is equal to n of A upon n of S, that is 2 upon 9. Okay, this is probability of red balloon. Then you have to go for blue balloon. So similarly, you will write down here, let B be the event that Pranali gets a blue balloon. Then you will write down total number of blue balloons and so on. Okay, so let's go ahead here. Let B be the event that Pranali gets a blue balloon. Now here how many blue balloons are there? 3. So write down that total number of blue balloons is equal to 3, and therefore here the number of elements in this particular event B are 3. And then you have to make use of the formula of probability. There we wrote P of A. Now here we will write P of B is equal to n of B upon n of S. That is 3 upon 9, which we can reduce further to lowest form as 1 upon 3. Okay. So the probability here is 1 upon 3. Now the third event. So write down that as event C. That let's see with the event that Pranali gets a green balloon. So how many green balloons are there? 4. So write down that total number of green balloons is equal to 4, and therefore n of C is equal to 4. And from that we can now write down P of C. Okay. So P of C is equal to n of C upon n of S, that is 4 upon 9. Okay, so this cannot be reduced further, so it will remain as it is. Okay, so all the things are very much similar, only you have to go on writing them properly. If you are not writing all these statements, you will not get marks. Take a note of this. Huh? Now let's go ahead towards the next question. Question number 6. A box contains 5 red, 8 blue and 3 green pens. Rutuja wants to pick a pen at random. What is the probability that the pen is blue? Okay, so here also you write down the number of sample points by adding these three things. Okay, that 5 plus 8 plus 3. So that total number of pens in the box you will get as 5 plus 8 plus 3, which is equal to 16. And from that we can write down n of s as 16. Number of sample points here in the sample space is what? 16. Now here only one event is there, so take it as A, that let A be the event that Rutuja gets a blue pen. How many blue pens are there? 8 blue pens are there, so write about that total number of blue pens is 8, and therefore n of A is 8. And then we can find out the probability by using the formula P of A is equal to n of A upon n of S. 8 upon 16, that is equal to 1 upon 2. Okay. So all the questions are very much similar. Let's go ahead now here. Question number 7. 6 faces of a die are as shown below. So here the 6 faces are shown, A, B, C, D, E and A again. If a die is rolled once, find the probability of A appears on upper face and D appears on upper face. Now here also you have 6 sample points. But what you will find is A is repeated. So you cannot write it as a sample space because repetition is not allowed in set. Okay. So you write down that total number of faces of the die are 6. Therefore n of S is 6. Don't write down that set because A is appearing twice, which is not allowed. Now let us take the first event. That event A is the event that A appears on the upper face. Now here, since here A is there, I have taken another letter, that is R. You can take any alphabet as I have said. So let R be the event that A appears on the upper face. Because A and A confusing, that is why it is not written. So here A has appeared 2 times. So let's write down that. That here total number of faces having A on it are 2, and therefore n of R is 2. And from that we can write down probability P of R as n of R upon n of S is equal to 2 upon 6, that is 1 upon 3. Okay, you can take any alphabet. Even if you take A, it's okay, no problem. Okay, now here A was already there, so I took R. Now let's see the second event. D appears on the upper face. So take it as any other alphabet. So I have taken now Q. Let Q be the event that D appears on the upper face. Now D is having only one. So only on one face D is there. Therefore, the total number of faces having D on it is 1, and therefore n of Q is 1. And from that we can write down P of Q as n of Q upon n of S, that is 1 upon 6. Okay. So as you can observe, all the problems are having similar structure. Only there is a little bit change about sample space because experiments are different. But rest all the method is absolutely same. Okay. Now let's go ahead towards the next question. Question number 8. A box contains 30 tickets bearing only one number from 1 to 30 on it. If one ticket is drawn at random, find the probability of an event that the ticket drawn bears an odd number, a complete square number. Okay. So let's start with the solution now here. First of all, you write down the experiment that a box contains 30 tickets and they bear the numbers 1 to 30. So here you can write down the set. Okay. So what is the experiment here? A box contains 30 tickets bearing only one number from 1 to 30 on each. That means the same statement is copied here. Okay, but it is important to write down that statement. And from that we can write down the sample space is as 1 to 30 all the numbers. Now here I have written all the numbers, but as I have said, it is not compulsory to write all the numbers. I have written them to make you understand, or every number should be in front of you, so I wrote it. You can write down 1 2 3 dash dash dash, and then in the end you can write down 30. It is assumed that the remaining numbers are present over there. Okay, so now n of s is 30 here, number of sample points. Now let's see the first event, that an odd number should be there on the card, or the card drawn bears an odd number. So take that as event A. So write down, let A be the event that the ticket drawn bears an odd number. So write down all the odd numbers from here. So they are 1, 3, 5, 7, 9 and so on up to 29. So from these 30 numbers, it is obvious that 15 numbers are even and 15 numbers are odd. So without counting also you can say that these numbers are 15. So n of A is 15. And from that we can write down P of A as n of A upon n of S. That is 15 upon 30 equal to 1 upon 2. Okay. Now let's take the second event here. A complete square number. Now start thinking about square. Square of 1 is 1. So this is one complete square number. Square of 2 is 4. So the next number is 4. Square of 3 is 9. So next is 9. Then for 4 we have 16. So next number is 16. Square of 5 is 25. So next number is 25. And square of 6 is 36, which is not present here. So we have to write down these 5 numbers. 1, 4, 9, 16 and 25, because we want a complete square number there. Okay. So let us write down the event now. That let B be the event that a ticket drawn bears a complete square number, and from that we can write down set B as 1, 4, 9, 16 and 25. And from that we can write down n of B is equal to 5. Then now it is very easy to write down the probability that P of B is equal to n of B upon n of S. that is 5 upon 30 equal to 1 upon 6. Okay, so I hope you must have completed it. Now let's go ahead towards the next sum. Question number 9. Length and breadth of a rectangular garden is 77 meters and 50 meters. There is a circular lake in the garden having diameter 14 meters. Due to wind, a tall from a terrace on a nearby building fell into the garden. Then find the probability of the event that it fell in the lake. Okay, so this is a little bit different question here. We cannot write down the sample space and sample number of sample points. Nothing we can write down. Okay, and here event is also a little bit different, which we cannot write in the form of set. Okay, so here this garden is rectangular garden. So first we have to find area of that garden. You know that the formula for the area of rectangle is length into breadth. So that formula we will use to find the area of the garden first. Then the diameter of the lake is given. From that we can find radius, and by using that we can find the area of this lake also. And then the probability we can find by dividing the area of lake by area of the garden. Okay, so let us start now. First of all, let us find out the area of rectangular garden, that is length into breadth. And from that we can find the area as 77 into 50, which is equal to 3850 square meters. Okay, so what we can write down, area of rectangular garden is 3850 square meters. Now let us find the area of the lake, and for that first let us find out the radius, because diameter is given here. In hurry, don't take this diameter as radius and don't find the area, otherwise you will get wrong answer. So here the diameter is 14 meters, therefore the radius here is 14 divided by 2, that is 7 meters. Okay, so finding this is very much important, because you know that area of circle is equal to pi r square, where r is the radius. Okay, so from that we can find the area of the circular lake, which is pi r square. So that is 22 upon 7 into 7 into 7. Value of pi we have to take according to our convenience. Now since here r is 7, we can take it as 22 upon 7, because 1 7 will get cancelled here. And then the area we will get 22 upon 7, 22 into 7, I'm sorry, that is 154 square meters. Okay, so now we have the area of rectangular garden and we have the area of circular lake. From that we can find out the probability of the event that the towel fell in the lake. Okay, so let's write down that. Probability that the towel fell in the lake is equal to what? Area of the lake divided by area of the garden. That is 154 divided by 3850. Now here, if you reduce it to the lowest form, you will get the answer as 1 upon 25. Okay, so you write the answer in the lowest form here. Now here you know that you can factorize and you can reduce it to lowest form. Okay, so you can do in any way. You can go for actual division, anything you can do, but you have to reduce to lowest form, and therefore the probability here is 1 upon 25. So the final answer is written in the words that therefore the probability of the event that the towel fell in the lake is 1 upon 25. Okay, so this was little different question. So all of you please copy it down and try to understand it. Now let's go ahead towards the next one. Question number 10. In a game of chance, a spinning arrow comes to rest at one of the numbers 1, 2, 3, 4, 5, 6, 7 and 8. You can see here, okay, this is game of chance, and here you can see this circular disc is divided into 8 parts, and then arrow, it can come to rest at any one point number. Okay, all these are equally likely outcomes. You know that in random experiments now here when we are thinking, the outcomes are equally likely. That means here the chance that the arrow will come and any one number is same. So find the probability that it will rest at first is 8, then second an odd number, third is a number greater than 2, and fourth is a number less than 9. So here we are given four different events. Okay, so let's find the probability for these four different events. First of all, write down the sample space. Here writing sample space is quite possible for us. Okay, so write down the sample space first of all. That sample space S is equal to 1, 2, 3, 4, 5, 6, 7 and 8. Because the numbers are already given there, so we are just writing them as a set, that is our sample space. And from this we can write down n of S as 8. Number of sample points here are 8. Now let's go towards the event. The first event. Let us take it as event A, that let A be the event that the arrow will rest at A. Okay, so write down that let A be the event that the spinning arrow comes to rest at 8. That means it will point towards 8. So here we have only one such sample point where we have 8. So our set A contains only one element, that is 8. And therefore n of A is 1. And from that we can write down P of A as n of A upon n of S, that is 1 upon 8. Okay, so the probability of the first event here is 1 upon 8. Now let's go towards the second event, an odd number. Okay, so let B be the event that the spinning arrow comes to rest at an odd number. Now from 1 to 8, write down all the odd numbers as set B. So set B contains these elements 1, 3, 5 and 7. And from that we can write down n of B as 4. There are 4 elements here in this particular event. And therefore we can write down probability of this event as P of B is equal to n of B upon n of S, which is equal to 4 upon 8, and in reduced form we can write it as 1 upon 2. Now let's go ahead towards the third event. Let's see with the event that the spinning arrow comes to rest at a number greater than 2. The number should be greater than 2. That means 2 is not allowed. Numbers which are greater than 2 are allowed, so we should start from 3 here. So here the numbers are 3, 4, 5, 6, 7 and 8, and therefore we can write down n of C as 6. 1 and 2 numbers are gone out of 8, so n of C is 6 here. Now let's write down P of C, that is n of C upon n of S, which is equal to 6 upon 8, which we can write as 3 upon 4 in the reduced form. Okay. Now the fourth event, that let D be the event that the spinning arrow comes to rest at a number less than 9. The number should be less than 9. That means 1 to 8, all the numbers will come here in event D. So such event is called as certain event. What you will find is that event D, the set is same as the sample space. So such event where all the sample points are present, it is called as a certain event. And the probability of certain event is always 1, because here n of D is also 8 and n of S is also 8. And therefore probability of this event P of D is equal to n of D upon n of S, that is 8 upon 8 is equal to 1. So keep this in mind, probability of a certain event is always 1. And previously we have seen one impossible event where the number of sample points are 0. So probability of impossible event is 0 and probability of a certain event like this is 1. Okay. Now let's go towards the next one. Next question. There are 6 cards in a box. each bearing numbers from 0 to 5. Find the probability of each of the following events: that a card drawn shows a natural number, a number less than 1, a whole number, a number is greater than 5. Okay, so here let us start with the sample space, that there are 6 cards in a box and they bear numbers from 0 to 5. So sample space S we can write down in the set form as 0, comma 1, comma 2, comma 3, comma 4, comma 5. Okay, so 6 cards they bear these numbers which we have written here, and from that we can write down n of s as 6 because 6 cards are there, so it's very clear that n of s is 6. Now let's see the events. Let A be the event that it bears a natural number. The card drawn shows a natural number. So you know that natural numbers they start from 1, so we cannot take 0 here in this event. So set A contains elements 1, 2, 3, 4 and 5, and therefore n of A is 5, and from that we can write down now the probability P of A as n of A upon n of S, that is 5 upon 6. Okay, now second event, a number less than 1. Okay, so let's take this as an event B. Let B be the event that the card drawn shows a number less than 1. Now here they are starting from 0. So less than 1, only one number we have, that is 0. And therefore here set B contains a single element, that is 0. And from that we can write down n of B is 1. And then immediately it is possible for us to write down the probability P of B as n of B upon n of S, that is 1 upon 6. Okay. Now let's go towards the third event. Let's see with the event that the card drawn shows a whole number. Okay, whole number. You know that whole numbers they start from 0. So here again all the numbers we will be having. So C is again a certain event as we have discussed in the previous question. So C here contains all the sample points 1, 0, 1, 2, 3, 4 and 5. And n of C is 6 here. And from that now you can write down the probability as 1. P of C is equal to n of C upon n of S. 6 upon 6, that is 1. Okay, so in this way here again we got one certain event where the probability is 1. Then the fourth event, let D be the event that the card drawn shows number greater than 5. Number should be greater than 5. See here also you can see the sample space. So here the highest number is 5. Number greater than 5 is not possible. So again this is the impossible event. See here the greatest number is 5. So this is an impossible event. Just now we discussed about the impossible event. So see here the impossible event came here, and therefore here D is an empty space or empty sample space here, and therefore the number of sample points here or the number of elements in these particular events are 0. Okay, so no element is present here. It is an impossible event, and therefore probability here is it will be 0. Okay, P of D is equal to n of D upon n of S, that is 0 upon 6, which is equal to 0. So what you have to keep in mind is the probability of impossible event is always 0 and the probability of certain event is 1. Okay. So students, today I am stopping here. The remaining sums from the problem set we will discuss in next lecture. Okay students, you practice all the sums. You know that this is the easiest chapter and here you can score the highest marks. So please do practice and keep in mind the easy formula of probability, that P of A is equal to N of A upon N of S, or P of B is equal to N of B upon N of S. You have to change it according to the alphabet which you have used for event. Okay. So students, today I am stopping here. We will meet in next lecture. Till that you stay home, stay safe, take care of yourself. Thank you students.